Our next topic is electric dipole in uniform electric field. Electric dipole in uniform electric field. Consider an uniform electric field of intensity E bar. E bar is the electric field intensity of this uniform electric field. Let an electric dipole is placed in this uniform electric field to make an angle theta. It is the direction of the electric field now. Here the axis of the dipole is making an angle theta. This is the direction of the uniform electric field. Here a dipole means a system consisting of two equal and opposite charges. Here is a negative charge, here is the positive charge with equal magnitude. Now here the negative charge will experience a force in this direction. This is the negative charge. Here you can write F is equal to minus EQ. F is equal to minus EQ. At the same time, this positive charge will experience a force in the direction of the field. F bar is equal to plus EQ bar. Here, two forces are equal in magnitude but are in opposite direction. The force acting on the negative charge is opposite to the electric field, and the force acting on the positive charge is in the direction of the electric field. As equal magnitude of charge, the force also equal in magnitude but acting in opposite direction. So that this dipole will experience a torque, but the net force acting on the dipole is equal to 0. One force acting towards right side, other force acting towards left side. But net force is equal to 0. Now, let us calculate what is the torque acting on this dipole now. We can define the torque as torque is equal to force into perpendicular distance. Force into perpendicular distance between the two lines of force. Force into perpendicular distance between the two lines of force. Here you have to find the perpendicular distance between the two lines of force. Here it is. The distance between the two poles is taken as 2a. This distance is taken as 2a, and this dipole is making an angle theta with respect to the electric field. Now we can resolve the 2a along the field and perpendicular to the field. Now this is 2a. Now in this direction we can write this is taken as 2a cos theta, and here this angle is 90. Now this is taken as 2a sin theta. This is 2a. This is 2a cos theta, and this is 2a sin theta, and the perpendicular distance between these two lines of force is equal to 2a sin theta. Now you can write the torque tau is equal to force into perpendicular distance. In vector form we can write tau bar is equal to r bar cross f bar. Torque tau is equal to r bar cross f bar. So you can write torque tau is equal to r means perpendicular distance between these two force. So you can write 2a sin theta into f. F is equal to what? E into Q. F is equal to E into Q. Here the force acting on the two charges are equal but are in opposite direction. F is equal to EQ. Magnitude of force F is equal to EQ. Therefore, we can write that is equal to 2 into Q into A into E into sin theta. That is equal to 2QA is nothing but dipole moment. We know P is equal to what? 2Q into A. Therefore, write P into E into sin theta. Now again you can write torque tau bar is equal to P bar cross E bar. So in vector form we can write torque tau is equal to P bar cross E bar, and tau is equal to PE into sin theta. In scalar form, tau equal to PE sin theta, and vector form tau bar is equal to P bar cross E bar. Under what condition the torque becomes 0? Suppose if this electric dipole is oriented in the direction of the electric field, then theta is equal to 0. That is, if theta is equal to 0, now torque tau is equal to PE into sin 0, that is equal to 0. So if the dipole is oriented in the direction of the electric field, the torque acting on the dipole equal to 0. If the dipole is oriented perpendicular to the electric field, that is, if theta is equal to 90 degrees, now you can write torque tau is equal to PE into sin 90. Sin 90 is 1. Maximum value of sin is equal to 1. Therefore, the dipole will experience maximum torque. Now, tau maximum is equal to P into E. P into E. If theta is equal to 180, theta is equal to 180. If theta is equal to 180, the dipole is oriented opposite to the direction of the electric field. That is, theta is equal to 180. Then also we can write torque tau is equal to 0. Sin 180 equal to 0, then torque tau is equal to 0. So whenever the dipole is oriented in the direction of electric field or opposite to electric field, torque acting will be 0. Whenever the dipole is oriented perpendicular to the direction of the electric field, and then it will experience a maximum torque. That the maximum torque is equal to P into E. P into E. Therefore, whenever an electric dipole is placed in uniform electric field, the net force acting on the dipole is 0, but it will experience only torque.